Okay, so here is an argument. I want to put it up on the board. Let's take a look at it. We'll break it down, and then I'll show you a rhetorically effective counterexample. All right? So here's the... Let me make a little bit more space here. All right. Okay, there's your argument. Some physicians are not medical professionals, but all surgeons are medical professionals. Therefore, some surgeons are not physicians. All right. First of all, this statement is an O. Hold on. Yeah. An O, A, O, 2. An OAO. Okay, the first premise, which by the way, here's your conclusion. This is your subject. This is your predicate of your conclusion. All right, so the predicate of the conclusion is right here. Here's your middle term. Your predicate is right there. There's your middle term. So you have some P are not M, all S are M, therefore some S are not P. Okay, that's an AOA2 statement. First thing we're going to do is test it by a counterexample. Can we change this conclusion to an obviously false conclusion and keep the premises true? If we have two true premises followed by a false conclusion, then we have an invalid syllogism. In rhetoric, we don't want to change the whole argument itself. What we want to do is counter it with one word change that demonstrates that this syllogism is invalid. So one word that we can change that demonstrates that this is invalid in a rhetorically effective way. All right, some physicians are not medical professionals, but all surgeons are medical professionals. Therefore, some surgeons are not physicians. If we take physicians and change it to people, we get some people are not medical professionals, which is true. All surgeons are medical professionals. That's true. Therefore, some surgeons are not people. So, again, what I'm demonstrating to you is something that your audience can pick up on. Rhetorically effective counterexamples. Let's look at another argument. And I'll show you again how a counterexample works. Let's see. Now there's an argument that you might hear somewhere along the road. This is an argument you might have heard already. Jesus was a pacifist because pacifists don't fight even to defend themselves, and Jesus didn't fight even to defend himself. Okay? Now again, we're looking for a rhetorically effective counterexample. Remember that this is the conclusion right here. And we know it's the conclusion because there's a premise identifier. And you might remember in the last lecture, or a previous lecture, we talked about the fact that the premise identifier will be followed by a premise. But when you have a premise identifier in the middle, the conclusion comes before it. So Jesus was a pacifist is the conclusion. Okay? Because pacifists don't fight even to defend themselves, and Jesus didn't fight even to defend himself. Those are the two premises. We're looking for one word in this argument that we can change that will make the conclusion obviously false, but will keep the premises true. Okay? Take a look at it. See if you can change one word. The terms here, Jesus is the subject, pacifist is the predicate. So here we have a predicate term, pacifist. Fight even to defend themselves is the middle term. Jesus is the subject. Fight even to defend themselves is the middle term. Okay? So Jesus was a pacifist because pacifists don't fight even to defend themselves, and Jesus didn't. So would you change Jesus, pacifist, or fight even to defend themselves? Let me suggest to you that you change the word pacifist. Okay? And let's change it, for the sake of humor, to the word puddle. I know that it sounds a little bit sacrilegious, but it illustrates the absurdity of the argument. Jesus was a puddle because puddles don't fight even to defend themselves, and Jesus didn't fight even to defend himself. Now there again we illustrate the fact that this argument, which appeared like a sound argument, is actually an absurd argument. And we illustrate that absurdity with a rhetorically effective counterexample. Counterexamples are really a powerful thing. You have to learn to use them, and I hope that you'll pay attention in rhetoric to the opportunities that you have to take what someone says, create a counterexample that will refute what they say. Now, that being said, the other way to determine the validity of a syllogism, besides counterexample will expose an invalid argument, but it won't help you find when an argument is valid. So we need rules that will tell us whether or not the argument is valid. So, here are the rules. A valid syllogism number one, a valid syllogism cannot have two negative premises. A valid syllogism cannot have two negative premises. And the reason for that is simple. You can't prove what something is by saying what it is not. All right? Look, I'm not the President of the United States. I'm not a congressman. I'm not a piano player. I'm not an African. I'm not a Martian. I'm not a chili pepper. I'm not a fruit. I'm not a nut. But that doesn't tell me anything else about what I am or what I'm not. all those what I'm nots don't say anything further about what I am, and they don't say anything further about what I'm not. All right, so you can't, remember your conclusion cannot go beyond your premises. So a valid syllogism cannot have two negative premises. Number two, a valid syllogism cannot have a negative premise and an affirmative conclusion. Okay? Now again, the reason for that is because the conclusion cannot go beyond the premises. So when you identify what a thing is not, you cannot say what it is. All right? I am mortal. I am not a pickled herring. But that doesn't, you can't conclude something from that at all about me. All right. Number three, a valid syllogism cannot have two affirmative premises and a negative conclusion. Again, in this case, the conclusion would be going beyond the premises, and the reason is because the premises only make a statement about what it is. They do not make any statement about what it isn't. Okay, number four, a valid syllogism must distribute the middle term in at least one premise. Okay, now I'm going to explain to you what I mean by distribution. In at least one premise, the middle term must refer to every member of its class. In other words, it must be universal. The reason is if the middle term is particular, if the middle term does not refer to every member of its class, then it is not connected to the middle term in the other premise. I pointed out earlier when we had the AAA2 syllogism, we have all P is M, all S is M, therefore all S is P. And I pointed out to you that these two premises are not connected at all. Because you're not, in neither of these premises are you speaking of every case of M. In order to make it valid, either you have to have all M is P, or you have to have all M is S. One or the other, but not both. And I'll explain why in a minute. But the reason is because you have to say something about all of M. Otherwise, these are two independent statements. They're not related to each other at all. And then if they're not connected to each other, then you can't make a conclusion from them. Okay, the fifth rule is that a valid syllogism must distribute in the premise any term distributed in the conclusion. Must distribute in the premise any term distributed in the conclusion. Okay? I said a moment ago that we would either have to make all M as P so that we're just referring to every member, all of M, or we would have to make all M as S. Again, referring to every member of M in the minor premise. But we can't do both. And the reason we can't do both is because when we're referring to all of M and all of M here, all M is P, all M is S, therefore all S is P. Here we're referring to all of S, every member of S, but here we only refer to some of S, because this S is not referring to every member of its class. So the all S is P here goes beyond, the conclusion goes beyond the premises. You're saying more about the S here than you are about the S here. Again, your conclusion cannot go beyond your premises. Okay, so these are the 5 rules for determining validity of a syllogism. Let's take this AAA2. No, we've already done this. Let's take some examples here. AOA1. All right. Okay, I put underlines where my middle term goes. I filled out the quality, all, some or not, and all. Now I need to fill in my middle term, my conclusion, so I get my S and P term. Okay, so I'll say all trucks are vitamins. All trucks are vitamins. That's obviously false. Okay? So trucks goes here. Vitamins go here. And I need a middle term, all of which are vitamins, and some trucks are not them. Okay? So let's see. All centrums, centrum pills are vitamins. Some trucks are not centrum pills. Therefore, all trucks are vitamins. Now, this is true, this is true, this is false. So with a counterexample, I'm showing you that this is invalid. But let me now show you why it's invalid. All right? Remember rule number 2. We cannot have a negative premise and an affirmative conclusion. Okay? So that rule is broken there. Our middle terms are distributed. Rule number 4, the middle term is distributed. But this term, trucks, we refer to all trucks here and some trucks here. So there are 2 rules being broken, number 2 and number 5. In general, in a syllogism, you must have the number of negative conclusions must equal the number of negative premises. Now you might be thinking, the number of negative conclusions, there's only one conclusion. That's right. But notice this rule. We cannot have two affirmative premises and a negative conclusion. And this rule, we cannot have a negative premise and an affirmative conclusion. And this rule, you cannot have two negative premises. So you cannot have more negative premises than you have negative conclusions. And that's why we say, again, the number of negative conclusions must equal the number of negative premises. So no two negative premises. If you have a negative conclusion, then you have to have a negative premise. But if you have an affirmative conclusion, like you do right here, then you cannot have a negative premise. So the best way to test is the conclusion negative or affirmative? If it's negative, then you have to have one negative premise. If it is negative, you cannot have more than one negative premise. If it is affirmative, then both of your premises must be affirmative. So the number of negative conclusions has to match the number of negative premises. Okay, and then the second rule is that at least one middle term must be distributed and if a term is distributed in the conclusion, it must be distributed in the premise. Okay, so those are the three things that we can check. If I can show this to you using this one, the way I test it is, first of all, I'm going to look to see if the number of negative conclusions matches the number of negative premises. Here I have an affirmative conclusion. Here I have a negative premise, so I know it's invalid right off the bat. The second thing I'm going to check is my distributed terms. I know that my middle terms have to be distributed. I've got this one and this one, and in fact, both of those terms are distributed. Because in a negative, if you have an E statement, no S is P, this is distributed and this is distributed. Remember, these are interactive. They're interchangeable. No S is P is the same as saying no P is S. We showed you that in an earlier lesson. Here, this term is distributed. All S is P because we're referring to all the S's. We are not referring to all the P's. For instance, if we say all beagles are dogs, we're not referring to all dogs. We can't say all dogs are beagles. That would be false. So those are not interchangeable. In this I statement, no term is distributed. In the I statement, we're referring to some of S, and we're referring to part of S that is P. So part of P. In this statement, the O statement, the P is distributed. Some S is not P. The not refers to all of P. So some S is not any of P at all. So it refers to every member of its class. All right, so here, some trucks are not Centrum pills. Is true, but we're referring to all the Centrum pills. So that is a distributed term. Now here, trucks is distributed, and here it is not. So I'm invalid again because a term is distributed here but not here. Okay, let me illustrate with another syllogism, and then we'll move on. I know this is great stuff. You probably, are either sleeping right now or just watching me in a daze and saying this is way over my head. But, not to discourage you or anything, I just remind you that this is, in a nutshell, this is everything that we teach to our 8th graders in our school, so you ought to be able to keep up with it. So some of you probably have rewound this a few times and are annoyed now to hear me lecturing you once again. But nonetheless, let me put up another syllogism. We'll do an E-I-3. Okay, so the E statement, no S is P. No S is P. I'm sorry. It's a figure 3. No M is P. No M is S. Therefore, some S is P. This syllogism breaks almost every rule in the book. Remember, again, we check the number of negative premises to the number of negative conclusions. We have no negative conclusion. We have 2 negative premises. So our first fallacy here is the fallacy of 2 neg prems, breaking this first rule. The second rule is also broken because we have a negative premise and an affirmative conclusion. So it's going to be the neg prem affirmative conclusion fallacy. We don't break the third rule, but then we check distributed terms. So the M is distributed in both premises. The S and the P are not distributed at all, so we're fine when it comes to the distributed terms that refer to every member of its class. So these are the 2 fallacies in this syllogism.